what we're going to do in this chapter. First, we're going to talk about what a binomial experiment is. The previous two questions are examples of binomial experiments. Bi, meaning two, allows us to classify the outcomes of a binomial experiment into two categories: success and failure. Okay, so the outcome of an experiment, remember the four basic outcomes for flipping a fair coin twice were heads heads, heads tails, tails heads, and tails tails. We're going to be able to classify those outcomes as either a success or a failure. In the previous example, getting tails would be considered a success, getting heads would be considered failure. Okay, let's look at Chapter 6.5 definitions. A binomial experiment satisfies the following four conditions. There are n identical trials. Now you've seen the little letter n, lowercase n, in use for the size of a sample. We are also going to use little n in this chapter to symbolize the number of times you are doing the experiment, and we call those number of times trials. So when we flip a coin 2 times, n is 2. If we flip a coin 10 times, n is 10. A binomial distribution is the result of a probability experiment that has been repeated a predetermined number of n times, and each repetition trial of the experiment is identical. So when we flip the coin 10 times, we want to make sure that the flips are identical. And by identical, we can talk about the type of coin we're using, or the height at which we're flipping the coin, or the surface on which we're flipping the coin. We want to make the conditions for the coin flip identical every single time. Okay, so if we toss the coin 20 times, n, little n would be 20. Roll a die 10 times, n would be 10. Okay, so we could do this for rolling a die, we could do it for flipping a coin, any kind of random experiment. The n identical trials are independent, meaning that each outcome or trial is independent of the other outcomes. So, for example, in the experiment of tossing a coin n times, the outcome of each toss or trial is independent of any other toss. So, you flip the coin once, it lands on a table, and then it rolls off the table and lands on the floor. That would not satisfy the rule for an independent trial, because landing on the table influenced the trial for landing on the floor. So to make it truly independent, you would flip the coin, record its result, and then flip the coin again without making subsequent rolls or flips dependent on previous ones. Okay, so each roll of the die is independent of any other roll of the die if we're talking about rolling die. And here's an example. Even though you flip the coin 30 times and you get mostly heads, it doesn't make the 31st toss any more likely to be tails. It still has a probability of 1/2. Okay, so oftentimes this is counterintuitive. People think that if they keep flipping the next, and they so happen to get many heads, they just think that the next one has got to be a tails. Well, the next one is it's no more probable of being a tails than any other toss. It's still 1/2. So each toss of the coin is completely independent of previous tosses. The third rule for a binomial experiment is that each outcome for each trial can be classified as either a success or a failure. Let's look at some examples. You decide whether the outcome is a success or failure based on the wording of the problem. Now we're going to have quite a few examples in this chapter, so you'll get practice classifying something as either a success or a failure. Success generally means a positive response to the question that's being asked, and we'll see examples of what that means. Okay, some examples of successes or failures. Suppose that the toss of a coin is either heads or tails. Maybe we're interested in getting heads, so success would mean getting a head. If we were interested in getting tails, success would mean getting tails, and the other outcome would be the failure. Okay, let's consider a multiple choice exam. The selection of a possible answer for a question on a multiple choice test is either correct or incorrect. So you have 4 choices on a multiple choice. Let's assume that there are choices A, B, C, and D. One of those choices is correct, and we can say that's considered the success. And the other 3 are failures. So those would be the wrong answers. Another example, the toss of a die results in an outcome which is either a 5 or not a 5. So let's suppose that we are interested in getting a 5. Rolling a 5 would be considered success. Anything else, not a 5, would be considered a failure. A new drug will either be effective or not effective. So if it's effective, we can consider that a success. If it's not effective, we can consider that a failure. Okay, and the 4th part of the binomial experiment is that the probability of success is the same for each trial. Okay, so the probability of the success is the same for each trial. This means that in a coin tossing experiment, the probability of landing on heads is the same for each toss or trial of the coin. So if you have a completely fair coin, the probability of getting heads should always be 1/2. The probability of getting tails should also be always 1/2. If you have a fair die and you roll it, the probability of getting a 1 should always be 1/6. The probability of getting a 5 should always be 1/6. And so when you're dealing with fair experiments, fair binomial experiments, you have the same probability of success for every single trial. Okay, so in rolling a die, the probability of rolling a 5 is the same, which is 1/6. And in conclusion, if those 4 conditions are met, the probability experiment can be classified as binomial. Then the distribution of outcomes is called a binomial experiment. Okay, so again with number 4, there are a couple of cases where you can think of a coin that is not fair, a coin that is more biased towards one side over the other. That would sway the probability for one outcome versus the other. And so the probability of success may not be the same each time. A loaded die could cause the probability of success to change each time as well. Okay, but if we do have those 4 conditions and those 4 conditions are met, we have a binomial experiment, and the distribution of all the outcomes of a binomial experiment creates a set of numbers called the binomial distribution. Okay, let's look at example 6.9. Consider the experiment of tossing a fair coin 5 times, where we are interested in getting a head. Can this experiment be classified as a binomial experiment? So let's go through the 4 conditions and see if we satisfy each. Are there n identical trials? Okay, so we're tossing a fair coin 5 times. Are there n identical trials? Yes, there are 5 trials, so little n is 5. The second condition, are the n identical trials independent? And we're going to say, well, if we flip that fair coin 5 times, let's assume that the experiment involves independently flipping the coins. So yes, the tosses do not influence each other's outcomes. One toss would be isolated from other tosses. the third condition. Can the outcome for each trial be classified as either a success or a failure? Okay, so let's assume that, what are we assuming here? We're interested in getting heads. Okay, so getting heads in this case, is considered success, and getting tails would be considered failure. So if we flip the coin 5 times, the outcomes can either be heads or tails. Anytime it's a heads, it would be considered success, and anytime it's tails, it would be considered a failure. So we satisfy this condition. So heads is success, tails is failure. And the last condition, is the probability of success the same for each trial? We're going to say yes, because this is a fair coin. We're assuming that we're flipping a fair coin, so yes, it's always going to be 1/2. Okay, with the 4 conditions being satisfied, we have a binomial experiment. The probability distribution for this experiment is a binomial distribution. Okay, so remember, the probability distribution is the set of all outcomes of a probability experiment, and in this case, the set of those outcomes creates a binomial distribution.